Hello friends, welcome back to the class of thermodynamics. In previous sessions we have seen first law of thermodynamics, numericals based on the first law of thermodynamics, okay? Now in today's session we will see about SFEE. What is SFEE? The full form of SFEE is steady flow energy equation. Note down. SFEE stands for steady flow energy equation. This is nothing but one of the step ahead to the first law of thermodynamics, or you can say application based. Okay, now there are some assumptions. Steady flow, what do you understand by steady flow? The flow which doesn't change with respect to time. The flow which doesn't change with respect to time is steady flow. Okay, now here we will take open system. There will be flow through the open system, and some assumptions are made here for the analysis. What are the assumptions? The mass flow rate through system remains constant. Mass flow through the system remains constant. Mass flow means mass of something flowing, means rate of flow of mass. Kg per second, mass per unit time, kg per second to the system is remaining constant. This is the first assumption. Kg per second is constant. Next, fluid is uniform, means fluid composition is not changing. If it is H2O, it is H2O only. Next, there is interaction between system and surrounding in the form of work and heat. The energy transfer between system and surrounding is in the form of work and heat. Next, the state of fluid at any point remains constant with time. State of fluid at any point remains constant with time, means steady flow. The fluid is not changing with respect to time. Now, here we are considering potential energy, kinetic energy and flow energy. These three kinds of energy we are considering here: potential energy, kinetic energy and flow energy. Now, see, this breaker, this is your device, this is your open system. This shaft, this system is mounted on some shaft. Some support is there, which is shaft. Okay, it's mounted on the shaft. Now here at the left hand side 1 section, this is the inlet, and this 2 is outlet. Okay, from section 1 the flow is coming inside, from section 2 flow is going outside. Now inside system there is some heat transfer, and outside it is insulated. Outside it is insulated, inside there is heat transfer. Now this inlet pipe, it is at height Z1. We have taken a reference line. From this reference line, the height of inlet is Z1, height of outlet is Z2. So the things given are: height is given, W represent the mass. This is nothing but mass flow. W1 is inlet mass flow, W2 is outlet flow mass flow. Next, heat transfer is dq by dt, and there is a shaft, it will rotate, so it will produce some work output. This system will produce some work output. How much? dw by dt. These parameters are given to you. This is a system, this is an open system, mass is coming in, mass is going out. There is some internal heat energy developed inside. This device is mounted on the shaft. There is some work output. Height is given, mass rate needed mass outlet is given. Now there are two things governing questions. One is mass balance, another is energy balance. You have to balance the mass, you have to balance the energy. Why? Because this is a kind of open system. There is mass transfer as well as there is energy transfer. So you have to balance the both. These are the notations. A represents the area in meter square. Mass flow rate represented by m dot. P represents pressure, small v represents specific volume, means volume is meter cube, specific volume means volume per unit mass. If something is written specific means it is divided by mass. Similarly, small u, specific internal energy, joule per kg. Velocity here it is represented by c. Why? It can be represented by v, but v is already used for volume. So velocity is represented by c. Now z is the elevation, height. dq by dt is heat transfer. Because it is per unit time means per second. And joule per second is nothing but watt. Joule per second is also known as watt. Similarly, work transfer, rate of work transfer, because it is per unit time, joule per second. And this is small t, this is nothing but time. And one represents the inlet condition, two represents the outlet condition. These are the important notations which will be used. Now see here, mass balance. Mass balance means conservation of mass. Means how much mass is coming inside, same is leaving the system. Mass flow rate entering the system is equal to mass flow rate leaving the system. Okay, this I have written in the words. So in expression, m1 dot equals to m2 dot. 1 is entering, 2 is leaving, and m dot is nothing but mass flow rate. So m1 dot means mass flow rate entering, m2 dot means mass flow rate leaving. So mass is given by area into velocity divided by specific volume. Unit of area, meter square. Unit of velocity, meter per second. So if we will multiply both meter square into meter per second, we will get meter cube per second. You will get meter cube per second. Now specific volume. Volume is meter cube. Specific volume is meter cube per kg. Right? If you will multiply this, you will get meter cube per second. And unit of this will be meter cube per kg. Now this divided by this meter cube will cancel. This will go out upward. We will get finally kg per second. Kg per second. This is nothing but mass flow rate. Mass per unit time. Okay? Is it clear? Now this is all about mass balance. And this is nothing but also known as continuity equation. Same thing is also known as continuity equation. Now next, energy balance. Energy in question energy out, first law of thermodynamics. Energy can transfer from one place to another, from one form to another. Okay, same thing. Energy entering equals to energy leaving. Now, what are the energy entering and what are the energy leaving? The energy entering is Q, heat. Next, internal energy, flow energy. We have seen in assumption, we will take flow energy. Next, we will take kinetic energy. Then we will take potential energy. So these are the energies entering. Energy leaving, work in place of heat. Now here it is work, and other things are same. Internal energy, flow energy, kinetic energy, and potential energy. Okay, so these are the energies. Now you can write like this also. This U plus PV, you know internal energy plus pressure into volume. This is nothing but enthalpy. So in place of U plus PV, you can write enthalpy. So if in question pressure, volume and internal energy is given or temperature is given, you can use this formula, above formula. If enthalpy is given, you can use this formula. Both are correct. What will be the unit? What will be the unit? Unit of internal energy is joule. So unit of this equation will be joule. Same thing for this also. Now per unit mass means joule per kg. Divide this by mass. U by m. In place of this is enthalpy. Per unit mass means specific enthalpy. If you are representing anything by specific, represent it by small letters. Okay? Divide by m, you will get C1 square by 2. Here you will get G into Z1. Similarly here. So this will be joule per kg, means per unit mass. So depending on the question, you will use the formula. So this is energy balance and also known as, this equation is known as steady flow energy equation. So you will use this equation only for solving the numericals. For different cases, you have to assume different parameters. Something will neglect, you will neglect, depending on the equation problem. Okay. So note down this very important formula. Based on this, lot of numerical will come. This is coming by energy balance. Okay. So thank you for today's session of steady flow energy equation. In next session, we will see how to solve the numericals based on these. Till then, take care. Goodbye.